This is part one of our lesson on human impact on the lithosphere. All right, obtaining resources. In order to obtain resources, humans must utilize one of the following methods: harvesting, mining, or drilling. And each method has an impact on the lithosphere and the environment. So, in order to survive, and also in order to create and utilize things that we enjoy utilizing to help make our lives easier, we need to obtain resources. This is something we've talked about in Earth Science class since day one. So, every method we have for obtaining those resources has some kind of impact on the lithosphere and on ecosystems and the environment in general. So let's talk about these three main types of obtaining resources. Usually, when we're obtaining food or some kind of material that comes from a plant, we use the word harvesting. So we usually use that word for gathering fruits, growing vegetables, obtaining meat. Even in hunting, when we kill an animal to eat, sometimes we refer to it as harvesting that animal. Wood, a lot of times we refer to that as harvesting when we cut down trees for wood and paper needs. And then when we obtain peat, which we'll talk about later, we refer to it as harvesting peat. Mining usually refers to any solid materials that come from underground: coal, metals, minerals, uranium, plutonium, so on and so forth. And then drilling usually refers to anything that's liquid that we get from underground, such as oil and natural gas. All right, agriculture overview. So here's some general things about agriculture that are important to acknowledge and remember anytime you're talking about growing crops. First and foremost, agriculture takes up land space. Okay, it takes space to purposely grow crops. Also, the land must be fertile. You have to have soil that contains enough minerals and nutrients to produce whatever crop it is you're trying to produce. And different crops require different minerals and nutrients. So planting the same crop again and again can hurt the soil's overall fertility. So you have to make sure that you're not using the same soil in the same way over and over again, or you can deplete the important minerals and nutrients in that soil. Furthermore, use of chemical pesticides, chemical insecticides, and chemical fertilizers can contaminate soil and affect soil fertility. So, organic fertilizers are best for maintaining fertility. Also, crop rotation is essential. This means that you can't, like I was saying earlier, you can't keep planting the same crop on the same land year after year. You need to plant different crops on different parts of land. You just have to rotate it. If you used a piece of land for cotton one year, you might want to use it for a different crop the next year, and then maybe a third crop the year afterward. And just kind of use different parts of your land for your different crops, and don't always use the same piece of land for the same crop over and over again. That's not even a new idea in science or anything. That's actually a very ancient idea. That's something that was discovered, probably not too terribly long, within a few thousand years of the start of agriculture. Probably it's old enough that directions for crop rotation are included in the Bible even. So that's not a new idea at all. All right, so the definition of agriculture is humans cultivating other life forms for food purposes. If you look up that definition, you might see other variations of it, but for our purposes, agriculture is humans cultivating other life forms for food purposes, growing plants, and raising animals to eat. All right, land must be cleared for agriculture. Okay, you can't really grow large crops in the middle of a forest or anything, right? And you can see here in the picture you have, a large field growing crops. It looks like strawberries here, and you can see forested area over here. So it's very likely that this whole area was forested until it was cleared to make room for farmland. Now, the problem with doing this is that it makes the land less biodiverse. Okay, meaning that, all right, the forested areas you had many different species of plants, trees, animals, but then when you clear the land for agriculture and then you plant your crop on it, you've reduced it down to only a few species. So now, whereas we had a very biodiverse forest here, now we have a single crop, and probably along with it whatever plants, I'm sorry, what other insects or other little pests or parasites exist, in this crop. All right, the word monoculture refers to farming of only one species of crop. That's like what you see in the picture. It looks like you just have a strawberry crop for, just covering the entire field. Now, monoculture is very attractive to farmers because it's really easy to maintain. If you're only growing one type of crop, then you've only got to maintain one type of schedule for everything. You plant it all at one time. All the different types of maintenance you have to do to the crop, you can do it all on one schedule. There's only a certain set of materials you need to buy, certain type of seeds and other materials to maintain the crop that you need to buy. It's labor efficient, it's cost efficient. So monoculture is, commonly practiced by a lot of farms. You'll hear people refer to a farm. This is a such and such farm. They'll refer to one particular crop. Although it's easier business-wise and work-wise, monoculture is not good for the environment and ecosystems, because you are basically, when you take, all right, so a general rule is the greater the biodiversity is, the more robust your ecosystem is. Okay, so if you have an environment that has many different species in it, if one species happened to go extinct or something, there are often other ones that can fill the gap that has been left. But if you have an environment where there are very few species and something happens to one of them, you can have an entire ecosystem collapse, and many other species, the few other species that exist, can die right away as well. So it's good to have as much different, as many different species as you can have in a given location, and it's it's not ideal to have only a few species. It's actually kind of dangerous for ecosystems. Furthermore, monoculture is bad for bees. Okay, so you have to think about this. You often ask students, how healthy would you be if you didn't eat anything but lettuce all the time? And students generally agree that lettuce in and of itself is not bad for you, but that if all you ever ate was lettuce, you'd be missing out on a lot of other nutrients and things you need. And the same is really true for bees. If they're only getting pollen from one type of plant, they're really missing the variety they need to be healthy. Furthermore, monoculture can hurt biodiversity in adjacent areas. So you have, a forested area here. You might have a lot more biodiversity, but then you have this open area here. You're using pesticides and insecticides, and also irrigation, and that can affect these natural ecosystems that are adjacent to this land in negative ways. All right, pests and pesticides. So when you grow crops, obviously, you're going to have bugs and other pests trying to eat off of your crops, and you want to keep them off of it. So generally, on farms, we use some kind of pesticide. And a lot of these are chemical pesticides, and they're really not the most ideal thing to be using. They're very effective, but they're also indiscriminate. Okay, like there's some organisms we want near our crops, such as the bees. Okay, we want the bees pollinating, doing their thing, because we need that for our crops to grow and for our plants to be healthy. But these pesticides, they may be bad for locusts and things like that. We want to keep off of the crops, but they're equally as bad for those bees. So, that's really, using chemical pesticides is not very ideal. Furthermore, when it rains on those crops or we irrigate the crops, the pesticides can run off and they soak into the groundwater and contaminate our groundwater. They can run off into streams, ponds, rivers, lakes. and contaminate the water. Pesticides also, like I was saying, they harm organisms and disrupt food chains. So if they kill a lot of insects that birds and other animals larger than those insects need to eat, it leaves those animals without a food source, and it can end up killing those animals as well when they're not even the target species. Now, fortunately, there are some very good alternatives to these chemical pesticides, such as pheromones. These are scents, chemical scents that animals put off to help attract mates. You can put those in areas away from your crops and draw certain species away from your crops. There's entomopathogenic fungi. It's a fungus that will not hurt your crops anyway, and really not hurt any of the organisms that are trying to eat it, but it'll keep them off. It'll make them not want to be around that fungus. There are certain bacteria and viruses, believe it or not, that are genetically engineered into certain species of crops that we eat, and that helps keep things off. And there's a lot of debate about how safe or unsafe that is, and that's a topic for another day. But that's just mention it right now as an alternative to chemical pesticides. Insect breeding interference. There's certain things you can do to keep the insects from breeding in the area of the crops that are not going to poison the environment in any way. And then natural pest predators and parasites are another thing. If you can get the right kind of insects on your plants, they will eat the insects that are trying to eat your plants, which is a very good thing. There are some stores that sell, gardening supplies, and they will sell insects such as ladybugs that will eat aphids and other bugs that are trying to eat your plants. So that's a very clean and natural way to control for pests and other parasites. All right, irrigation. So it doesn't always rain enough when we need it to. So probably pretty soon after agriculture was conceived and began in the first place, it was discovered that sometimes you need to irrigate. You need to water your crops because it's not going to rain enough. All right, irrigation helps because we don't have to rely on that regular rainfall. Okay, it makes it more likely that we're going to, produce a healthy crop, a viable crop, and it not fail due to lack of rain. And it helps saturate very dry land and keep the soil in place. But there are drawbacks. Groundwater can be used up. We call this aquifer depletion. We've talked about this before. You can use up the groundwater in an area, and then you don't have that water source anymore. Also, if that happens, the ground can sink. It can also lead to sinkholes forming because water used to fill some of those voids underground. And when you remove all the water, you've removed part of what's holding the surface up. Also, if you irrigate too much, it can cause water, like we said, to mix with the pesticides and cause groundwater pollution. Just a lot of problems associated with irrigation. So we have to try to make sure we only irrigate just as much as we need to, and that we're not over irrigating. All right, overgrazing is the removal of excess amounts of plant growth by animals. All right, so you have pasture, and the animals eat the grasses and other plants on that land. Now, in our area, it's not really likely that animals will decimate all the plant life in their pastures, but in some parts of the world, this is a possibility and happens. So when animals overgraze and eat too much of the vegetation, this accelerates erosion, and then that can result in a loss of topsoil, and that's going to render the soil infertile, and then it can't grow plants anymore, and you've lost the plants, and you've lost that rangeland or those pastures for those animals. So the way to avoid this is much the same as how you avoid using up all the minerals and nutrients in soil. You just rotate your pastures. You just take the animals here, let them graze for a while before they can do too much damage to this pasture. You take them on to another one. I've seen this actually in some TV shows. There's some TV shows about Alaska, and some of those people raise cattle, and they move them from pasture to pasture to help maintain their rangeland. So here in the picture you have an example of overgrazed land. This land was overgrazed by sheep, and they ate too much of the vegetation. Now there's not a whole lot that the sheep can eat anymore, and the soil's been rendered kind of dry and infertile. All right, tree cutting and deforestation. Trees are cut in order to clear areas for construction or farming. Also, we cut trees to obtain wood for products that we need, like paper, furniture, building materials, firewood. Clear cutting is when loggers go into an area and they cut down all trees and none are replanted. They cut down all trees regardless of age, and none of them are replanted. There are some legitimate reasons for doing that. Like if you wanted to clear the land to build a new building, like a business, a home, school, so on and so forth, or to make some farmland, clear cutting is something you would have to do if you want to turn forested area into a developed area, which really we should try to do that, as least as we can possibly do it, but it's a thing. All right, but clear cutting can lead to deforestation, which is the destruction of forest ecosystems due to the cutting down of trees. All right, so anytime we can avoid clear cutting, we need to, and as we're going to talk about in a moment, there's a lot of incentive to avoid clear cutting. All right, so with deforestation, you also have increased erosion. All right, so you're removing trees and other topsoil. And other vegetation, and that weakens the topsoil. It allows it to get dried out and makes it loose because you don't have the roots holding it in place and moisture holding it in place, and you can have increased erosion. In the picture here, you see rainforest that has been removed to make farmland, and actually, this is bad for more than one reason. We don't want to remove our trees, especially in our rainforests, which we consider to be the lungs of the earth because they're making this oxygen for us to breathe. But also, when you cut down rainforest to make farmland, the land usually isn't as fertile as you would think it is, because a lot of the nutrients that were making the rainforest such a biodiverse and fertile place is all right there on the surface. And when you cut down all the trees, you actually end up removing or drying out all that organic material that's on the surface too, and the actual soil beneath is not near as fertile as imagined. All right, so if more trees are cut down, like we said before in our science class, carbon dioxide levels increase, oxygen levels decrease, and we don't want that. All right. Photosynthesis removes carbon dioxide from the atmosphere and releases oxygen, and we need to maintain a balance. We need the right amount of carbon dioxide. We need enough that the earth is warm enough to support life, but we don't need too much because it can get too warm, and then end up being the earth can be kind of inhospitable because of that. And we don't need that. So the less trees means less photosynthesis, means more carbon dioxide in the atmosphere, less oxygen, more global warming, climate change, and the problems associated with it. So we want to preserve as many of our trees and plants as we possibly can. So clear cut and deforestation, really bad for us. We really need to control that and prevent it as much as possible. Selective cutting is one of the answers to this. It's an alternative to clear cutting, and it can prevent deforestation. What you do with selective cutting is, instead of going in and cutting all the trees in an area, you make sure to pick out only the most mature trees, the mature older trees that are going to yield a lot of whatever it is you're needing, a lot of pulp for paper or a lot of lumber for building materials and furniture and whatnot. So you cut down only the most mature, oldest trees. You replant a tree for every one you cut down, and then you leave the less mature trees to continue to mature. So what that does is creates a situation where you always have some trees in that area coming to maturity that you can use, and you can use those trees, and you've always got some more growing right back in its place. You've got different levels of different levels of tree age. So like I said, you always have some trees coming to maturity, and it maintains the supply of trees. So this method is not only good for the health of our forests, it's really good for business too, because if a logging company goes into an area and they cut down all the trees and they don't replant any, and then trees never grow back, I mean, that area that was once good for harvesting trees is now worthless in that sense. So if you have an area that you can always go and get some good trees from, then that's always gonna be better for business. So fortunately, selective cutting is one of those things that's environmentally friendly and economically friendly. Here's a picture of an area that's been heavily logged and clear cut, and unfortunately, it's also very sloped, so you have increased erosion and all those problems we were talking about that are associated with deforestation. All right, let's talk about peat a little bit. Peat is an accumulation of partially decayed vegetation. It's basically humus that we were talking about in the soil lesson. It's organic material that is breaking down, and it's developed. It's more developed than more recent humus, but it's not quite as developed as say fossil fuels deep down in the earth, which take millions of years to develop. So this material that constitutes peat, it is pretty old, but it's not that old. However, peat is useful for being burned as fuel like fossil fuels are. And furthermore, you can use it as fertilizer. It's really good for adding nutrients and minerals to soils to make them more fertile. So peat is kind of a good material to use. It's renewable as long as you don't take too much of it too quickly. Now, harvesting it can disrupt ecosystems where it's found because you dig it out of the ground. But fortunately, you don't have to go very deep for it. Unlike drilling for oil or coal mining, you don't have to go very deep. It just, like you can see in this picture here, they're going a foot or so below the surface to get the peat. All right, now peat has some advantages over coal and other fossil fuels. It has low sulfur and mercury content, so when you burn it, you're not putting sulfur and mercury into the atmosphere. Also, compared to coal, it has a very low ash output, so you can burn peat and it does not create near as much ash as burning coal. And in terms of economics, peat's value is pretty much equivalent to coal, meaning it's worth the same. It's worth the same amount. It's less expensive than oil and natural gas, and it's price competitive with biofuels such as biodiesel and ethanol. Machines that burn coal to produce electricity at power plants can pretty easily be updated to burn peat as well. And you can update them to burn a coal-peat blend, which is better than burning just coal. Or you can alter them to where they can burn pure peat. And like I said, burning peat instead of coal is, it doesn't pollute as much, and it doesn't produce as much waste left over in the form of ash. Since peat forms near the surface, like I was saying, it requires less digging to harvest. So peat's not a perfect fuel source to be using, but compared to coal, it's much better. In future lessons, we're going to talk a lot about alternative energy sources, and many of those, if we diversify and use enough of those, we probably won't have to use peat anymore either. We can probably discontinue it with coal and oil and natural gas and other fossil fuels. One last thing I should probably say, I've been talking about peat alongside fossil fuels, but peat is not itself a fossil fuel. It's not that far developed. Peat is considered to be a no, I forgot the word now. It's considered to be biomass, which is the organic material that is broken down and decayed to a certain point, but nowhere near as developed as fossil fuels are.